So today we're going to start off talking about lighting, and we're going to finish up our lighting section. We don't have that much more left. And then we're going to jump into chapter 57. And chapter 57 deals with advanced driver assist systems, often called vehicle autonomy. If I have enough of them, we're going to talk about what vehicle autonomy actually is. I have some videos that I shot that we put together for showing some of the autonomous features we're going to talk about. Chapter 57 also covers the drive-by-wire system. And I don't cover that in the lecture in chapter 57. I save it to really talk about it more when we get into fuel systems and air induction, because that's really where it belongs a little bit more. So even though you're going to read about it in CDX on this chapter, I'm not going to cover it in the lecture or on any testing. I save it for the fuel system module that's going to be coming up in several weeks. And then we're also going to talk about airbags. So next week we're going to get in, we're going to talk about airbags, get a little more technical with airbags. But I really spend a lot of time, just like we did on lighting, on how airbags work and what we're doing with them and the different pieces involved. And certainly airbags have come a long way since the 1980s. They have evolved a lot in technology and how many of them we have on a car today. And so what I will do is I will give you something to think about over the weekend is, if you were in a head-on collision, would you rather be in a 1959 Bel Air, all that chrome, steel, big, heavy car, or a 2009 Chevy Malibu? And we know new cars are a lot lighter, a lot of plastic and that kind of stuff. And if you're in a head-on collision, which one of those two would you rather be in? And I'll let you think about that. And I'll ask that question again next week. So I wanted to give you something just to kind of think about. And we'll look at that next week when we talk about airbags. So today, we start off lighting with daytime running lights. So we talked about headlights. Daytime running lights are lights that are not as bright as headlights, although they may use the same light bulb. So what some systems do is, where we run the headlights in parallel, so they each get 12 volts. For daytime running lights, we'll run those same lights in series. So now each light bulb is only getting half of our applied voltage. So if we're running at 14 volts, that'd be 7 volts each. So instead of each light getting 14 volts each, we'll only get 7. Other manufacturers have special daytime running light bulbs or other things. So it's a completely separate circuit. Daytime running lights are not required in the United States. Interesting enough, they are required in Canada. And they are designed around daytime safety. It's much easier to see a car coming towards you if you're on a 2-lane road that might be passing or in your lane if it has the headlights on. And most of you have probably driven on roads where it says daytime headlight area next 20 miles or something like that, where you have to turn on your headlights for a period of time based on the road conditions, or they're doing a test. And they've been doing that for 30 years plus, where you had areas that they want you mandatory daytime headlight area. And so it's been proved that having those lights on during the day makes vehicles safer, makes driving safer. So my question would be, if it saves lives, why don't we require it? We require other things. We require backup cameras in cars. We have since 2015, because every year a couple of people would get backed over, usually little kids. So we've required backup cameras on every vehicle, and backup cameras, really, there's some expense involved there. This is simply a matter of adding another switch in a circuit. This is pretty minimal cost, but yet we've chosen not to mandate it, which I just find interesting. Because we talk a lot about safety. We put a lot of very expensive things on cars for safety. Here's something very cheap that we don't do. So I just find that, it's always interesting when you listen to what's being said. And as you learn about technology, you go, why don't we do this? It would add almost nothing, literally, to the cost of an automobile. and it would save lives, but we don't require it. Many vehicles have it, but it's not required. So kind of food for thought, isn't it? You know, because automotive industry, as we've learned, especially with lighting, a lot of regulations, a lot of requirements, a lot of things, but this is something that we don't require as of yet. So smart lighting, and in the discussion board, I direct you some different types of smart lighting. So automatic headlight leveling systems ensure the headlights are always correctly aligned, regardless of the load the vehicle is carrying. So you can see this could be a big advantage for not only a passenger car that someone went to Costco and now it's loaded down, but you know, your car's going to ride differently. Do you have 3 people in the back seat or nobody in the back seat? Do you have luggage in the trunk? No luggage in the trunk. How about trucks? Do trucks change a lot based on whether they have a trailer or how much load they're in? So, you know, currently trucks, I normally don't have this automatic leveling, but you can see where the technology, it's a safety thing, and you can see why more and more manufacturers are using it. Again, not required. Auto leveling headlamps use a sensor to monitor the angle of the vehicle to the road. Adaptive headlights adjust their length of the headlight beam based on distance of oncoming traffic. Dash mounted camera determines the distance of the oncoming traffic and relays the information to a module. And then based on programming, that module's going to make a decision. So here we go right here. So here's a beam adjust motor, has a little servo motor in there, and it's going to tell, are we loaded or unloaded? And based on that, it's going to adjust the headlight angle. This is cool, headlights that shine around the corner. So someone brought that up yesterday, I think it was you, Christopher, about headlights that turn a little bit with the steering wheel. They're not going to turn all the way with the steering wheel, and small turns, they're not going to move at all, but they're going to change their amount of turn based on the speed of the vehicle. So it's not just, you know, a mechanical connection. We got to look at the speed of the vehicle and how many degrees the customer's turning the wheel. And based on that, it's going to change how many degrees they turn the headlights. And so you can see now that lighting system is a lot more than just a switch. It's in series to a couple bulbs in parallel to make them come on and off. Now what we have to have a module or several modules that are sharing information. So because I got to talk to steering. Steering's a module. How many degrees are you turning? Where are you at? I need to talk to the engine management system. How fast are we going? I need to talk to the lighting system so I can tell these headlights what I want them to do. So you see there's a lot of discussion going on between these modules to make this stuff happen. So these are a lot of interesting technologies out there that are being played with, largely on high-end vehicles. We see some of the technology trickling down, just like daytime running lights used to be on more expensive vehicles. Now we see them on most vehicles. Because as these features come out and as customers like having them, and as those expensive vehicles get into the secondary market where they're competing with people buying new vehicles versus a much higher end used vehicle, some of these features start coming in, and that puts pressure on the manufacturers to try to add them to lower line vehicles. So some manufacturers add the ability to shade or block light within a beam based on position of oncoming traffic. In other words, I'm not going to shine my lights in your eyes anymore, but all around you so I can still see the road. I'm just not shining them at you. Some types of headlights swivel slightly through the horizontal plane to shine around the corner, which I already showed you. So our computer controlled lighting systems use an ambient light sensor to determine when the light levels are low, and then the computer turns the headlights on when set on automatic. So my car has this. It uses what's called a sun load sensor or sunlight sensor, or a couple other names for it. And we see here they're calling an ambient light sensor, which is interesting because I've never seen it called that on a car. You have an ambient temperature sensor on a car, but normally the light sensor is called a solar sensor or sun load sensor. And that's used by not just my lighting system. What other system do you think might want to know if the sun's out? What's that?
HVAC.
HVAC, absolutely, air conditioning. Because my AC needs to work harder to keep you at 72 degrees when it's noon than it does at midnight. So the climate control system needs to know what the sun load or how much energy we're getting from the sun to help correctly maintain the right temperature inside the car. So the sensors originally were could have been used for the HVAC system and then shared with the lighting system, or they could have originally been there for the lighting system and then shared with the HVAC system. And the reality is both are true. So if I'm trying to diagnose this system, say my headlights don't come on at night when they're on auto. Well, first thing I need to ask is, how does the car know it's nighttime? Which should lead me to a sun load sensor. At that point, I need to ask myself, who is the sun load sensor attached to? I can't assume it's the lighting module. So I would need to look at a schematic, find the sun load sensor, find out which modules the wires go to, and that's the module I would need to talk to with the scan tool to see what it's seeing. But it all starts with what? A question. I know how the system works, right? It gets dark and the lights turn on. How does it know? So you can see we take it from a basic concept of the lights come on at night to a basic question, how does the car know? And from there, we can start our investigation and figure out what sensor it's using, who it's attached to. And if it's attached to someone other than the lighting module, then we know that those modules have to be sharing information. So I need to, is the module seeing the signal? Is it sending out the message? Is the other module getting the message? And we're going to look at some basic networking a little later on this morning.
So Brian,
Yes.
is it the light that it's sensing, or is it the heat that it's sensing?
It's sensing the light, because I
Just
can
the
actually
light.
put my hand over it, or my dash mat, if it slides over it, will cover it up
Okay.
enough to where it thinks it's night.
Okay, because I was thinking, when it's daytime, it's hotter, so it will sense the heat.
No, we have
well.
other sensors that measure temperature. So we do have an outside temperature sensor or ambient temperature sensor. So we are measuring that. And we're measuring that a couple different places. We're measuring it normally for our climate control system, so it knows how hot it is outside on many of these systems. We also have a sensor in the engine that measures the temperature of the air going in the engine. And depending on the placement of that sensor, it may or may not be reading what the outside temperature is, or it may be reading slightly above the outside temperature, but it still can give the computer some information that it might share. So we do actually have temperature sensors on the outside of many cars, and we have temperature sensors on the inside of many cars. So if you have a smart climate control system where you're able to tell it how many degrees you want, you're not just turning the dial like I do between blue and red and somewhere in the middle, but if you can actually put in your degrees that you want, you have air temperature sensors guaranteed both inside and outside the vehicle. If you have driver and passenger controls, you're going to have temp sensors on the driver's side, temp sensors on the passenger side, and temp sensors outside.
Okay, thank you. So many sensors, huh?
Well, again, what do we want to do? If I want the passenger's temperature different than my temperature, and I'm not saying just hot or cold, but I'm saying that the passenger wants to be at 76 and I want to be at 72. How am I going to measure that? I need a thermometer, right? So if I'm a computer, I'm no different. I need a thermometer, but in computer talk, that would be a temperature sensor. So I fix a lot of cars by putting myself in place of the computer. If I'm in a computer, what would I need to make this decision? What would I need to make the air 72 degrees? How would I know it's 72 degrees? What do I need to change or turn on to make it 72 degrees or turn off? And that really and that's, one example. Another example would be a convertible top. Convertible tops now have computers. So if you're pushing the button and your convertible top doesn't go down, you need to ask yourself, Well, if I'm the convertible top computer, what would I want to see? So many of them I can talk to and get codes, but if I have a code, it kind of tells me what hurts or what sensor might be bad or something like that. But I also have times that convertible top's not going to go down, but there's no codes.
And if you really need something, maybe finally go put your phone or your tablet on the charger so that you can have it for later. You're not going to use mine today.
That might be an instance where it's talking to like maybe like a vehicle speed sensor, because I know it probably won't attempt to go down at like at freeway speeds. You know, would
or
that
any
be all?
speed, probably, right? I mean, we don't want to be coasting even across the parking lot. So vehicle speed sensor could keep you, but it's not going to set a code. It just thinks you're driving down the road. Why would I set a code? You hit the button the wrong time. I did a great job. I saved your top from blowing off at 70. So that's one example. Absolutely. Another example might be the parking brake's not on. And if the manufacturer wants the parking brake on, or maybe the car in park, right? So you're sitting there at a stoplight and you hit the button to put the top down because it's a nice day. Well, you're in drive. Maybe the computer's not going to let the top go down because you're not in park. It thinks it's doing a great job. Why would it set a code?
Wired through that same neutral safety switch.
Exactly. And so what if my switch is bad for my parking brake? So the car never knows when I put the parking brake on. I'm not going to get a code for that. They just think I never used the parking brake. So I'm never going to get a code. But yet my convertible top won't work because of a bad switch. So there's an example of I have no codes in the car at all. Car thinks everything's great, but I have a bad switch. Because the logic says this person just doesn't use the parking brake. I don't see anything wrong here. They just haven't put it on. So, when we have a car with a problem, we tend to, we want to understand what the customer's experience, what's the complaint. And then we want to hook up a diagnostic tool on a modern vehicle to see what computers see a problem. And occasionally, and a lot of times that gives us an area to go look. It's no different than when someone, if you have a kid that's not feeling well or an animal's not feeling well, you kind of check their temperature, you kind of feel them. Are you sore? You kind of go through these basic things to kind of try to get an idea of what's wrong. The same thing we're doing with a scan tool on a car. But occasionally it comes back and says the car doesn't see anything wrong, but something doesn't work. And that's when you really need to put your mind into where, okay, if I'm the computer, what would cause me to think I'm doing a great job and not set a code? And then that's normally an input issue, because if it was an output issue, computers are pretty good at recognizing that. Hey, I turned this on and I didn't see it move. Boom, I'm setting a code. But if an input signal doesn't change, it may not set a code, especially a switch signal. And so then it stops things from working. And I fixed a lot of cars that other people haven't been able to fix. Not because I had better tools, not because I had better information, but because I was able to say to myself, what would keep this from working? So for example, BMW has a door, when you close it on a convertible, the window goes up about this far. And as soon as you open it, the window drops down about this far. And it's to keep it from getting stuck in the rubber over on the convertible top. And I had a customer complain that their window wasn't going up that last little bit. And this was an older BMW. So there was nothing the scan tool was telling me. And I couldn't talk to it. So, I could go just start testing stuff, but I had to think about, how does the computer know the door is closed? Well, the door latch had a switch in it. Oh, so if I go to the other door that's working and I just move the switch, does the window do this? Oh, it does. Now let me go to the one that's not working. Does the window? No, it doesn't. Well, the motor had to be good because it goes up and down. It just doesn't do that last little part. So therefore, it has to be a problem with that switch. So I went and checked, made sure it was plugged in. It's a switch circuit, so it has either power or ground on one side and nothing on the other, and it has to change continuity, not continuity, right? My signals should be the same when it's in one position and different in another position, and the switch never changed. So it needed a new door latch. So this is with no fancy scan tool. This was with no factory manual that talked how it worked at all, because there was no information on it. But it was strictly going, okay, here's what it's not doing. What makes it do it? And a lot of fixing modern vehicles is the ability to apply that logic. You know, that's how we really get ahead, because that's not in the manual. It's not going to give you step by step. You need to be able to, I always say, ask questions. What makes it do this? Why does it do it? So automatic dimming headlights have been around for a long time. Use a light sensor located in the front of the vehicle on the dash to detect oncoming vehicles, and will automatically kick you from high beam to low beam. Most vehicles have an adjustable knob that sets the sensitivity of the light sensor. So you can say, do I want it to turn off when the car is really close or when the car first arrives? Delayed off feature allow headlights to be left on for a certain period of time after the engine stops and the doors are closed and locked. So this is really nice. Coming home at night and everything's dark and your car set up so the lights stay on for a minute or 2 minutes after you shut the car off and lock it. And that gives you light to get in the house. Some vehicles, the control module turns the headlights off if the headlights are left on after the ignition is off and the driver's door is left open. So again, we have a timer. All computers are a clock. All computers have timers in them. And if the computer's programmed to turn things off after a certain period of time, maybe 10 minutes. Hey, the door's open, lights are on, it's been 10 minutes. We know you want to start this car again, so we're just going to turn everything off for you. On other vehicles, headlight warning alarms sound if the headlights are left on after the engine has been turned off and the door is open. My Jeep does this. It beeps at you if your headlights are on and the engine's off when you open the door. On some vehicles, the BCM illuminates a warning light on the instrument cluster to tell you you have a bulb out. So in this case, you can see the bulb out light. This just tells me I have a light bulb out. I don't know which one. Don't know which side. Don't know if it's a tail light bulb, a headlight bulb, a turn signal bulb. I have no idea. So one way to narrow this down, aside from going and looking at everything, and sometimes it's very hard to do that. What I can do is I can start the car and see if the light comes on right away. If it does, it has to be something that's already turned on. So if nothing's turned on at this point, the light should be off. Now I can turn on the parking lights. Wait about 10 seconds. Does the light come on? Oh, it's not on. Let me turn on the headlights. Go the next click. Is the light on? Nope, the light's not on yet. Now let me step on the brakes. Does the light come on? And I'm staying on the brakes for about 10 seconds. Oh, the light just came on. Guess what? I have a brake light out. Because it's going to kick as soon as it sees the circuit that's bad. So if I start with all the lights off and turn them on one at a time and give them 10 seconds or so on each step and give the system time to react, the system will tell me what I'm looking for. I'd rather go look to see which of my brake lights are out than have to go inspect the whole car. And I get to do that from the comfort of the driver's seat. Again, if we understand what it's doing, we can use it to help us fix the vehicle. So the BCM can be programmed to command the interior lighting to remain on after the doors have been closed and set for a period of time. We talked about that yesterday with our courtesy light. So that kind of wraps up lighting. Just really gives you an overview of the different lights on there and where we're going with lighting. And the Sylvania articles will kind of take you to that next step, and they're awfully good. So I'm going to take a minute here and we're going to talk about networking or multiplexing. So we do have a networking chapter module where we're going to go much deeper into this. But this right here is really very basic. But by the same token, it also has some discrepancies in it. And since it's in the book, I kind of wanted to clear some of those discrepancies up also. So a bus is combines all the individual systems whenever possible into a multiplex serial communications network. So what we're saying is we can take all the modules on the car and network them. In reality, we can have several networks on the car, which I'll show you when we get into my networking PowerPoint. This allows for less wire on the vehicle, less weight, fewer connections, so there's less chance of faults or failures. A single or multiple network consisting of one or more twisted pairs of wires carries digital information throughout the entire vehicle. So not all networks use twisted pairs. Not all networks use two wires, contrary to what the book says. We have single wire networks. We have two wire networks that do not use a twisted pair, and we have two wire networks that use a twisted pair. And a twisted pair is a set of wires that are literally just that, twisted. And they twist them in order to shield them from electromagnetic interference. So some networks need that shielding, other networks don't. Obviously, a single wire network is less expensive and slower than a two wire network, and many of our systems don't need a super fast network, so we can save money by building a slower network. And all network data or information is shared throughout the vehicle. Well, it's only shared where it's told to be shared. So not all information is shared. For example, if my module on my steering wheel is telling my cruise control to turn on, that's going to talk to my instrument cluster, that'll talk to my powertrain control module, that if I have a separate transmission module, also talk to it. But it's not going to go tell the lighting module I turn cruise on. So keep in mind, these signals, because we have separate networks, and the reason why we have separate networks is because if a network goes down, we don't want the whole vehicle to stop working. So we compartmentalize it into different networks, so there's some protection and some redundancy. So if we lose one network, we still have other networks. The idea is to try to keep the car running. But we do have the ability to share information throughout the vehicle, again, based on structure and programming. So on many vehicles now, we have a rear signal acquisition module, and that's Mercedes' name for it. And it controls everything in the back of the car. So it controls everything from the fuel pump to the brake lights. So if it's happening in the back of the car, it's controlling it. It has its own fuse box back there, as a battery, and it basically gets a signal from the modules in the front of the car telling it, hey, I'd like brake lights now, or hey, we need tail lights, or can you turn on the fuel pump, or can you open the trunk, or any of those things are all done by that rear module. So that's a network system. We're asking, one module is asking another module to do the work. The system is often referred to as controller area network, or CAN bus. CAN is a specific network protocol, and there's actually 4 different kinds of CAN that we'll look at in the network module. But so most of the, I shouldn't say most, many of the networks that we see on automobiles are actually not CAN networks. We do, since 2008, we have to use a CAN-C high-speed network to talk to the scan tool through the diagnostic link connector for OBD2. But we still have other networks that go to the diagnostic link connector on some vehicles that use other protocols that may not be CAN. So again, the book, the concept of networking is okay. In the book, the details are not quite correct. They're overly generalized and not accurate. But here we can see our twisted pair. And here we have the headlights. So I have a body control module, and we're coming up and I'm talking to both of the headlight modules. Now, if you notice, they're calling the headlight modules nodes. Node is the same as saying a module. It's just a computer term they use in automotive to confuse us because it makes too much sense to only have one name for something. So we had to use another name that sounds much more technical. So they had a reason for us to go back to school because none of us knew what a node was, even though we knew what modules were. And then when we were surprised, they were, oh, that's a module. So a node is a module. So A thin twisted pair of wires connects all the onboard control modules to each other within a specific network. So there's not one twisted pair that goes throughout the whole vehicle. There's not one twisted pair that connects to every module in the vehicle. Normally, our CAN high-speed network only has about 5 modules on it. And then we have medium speed and low speed networks that operate separately, but have the ability to share information with the high-speed network. If there's something the high-speed network has that it needs, so that's in the programming, or if there's something in the low-speed network that the high-speed network needs, it's able to get it also, but that's all based on programming. So not everyone's talking to everybody. It's a matter of who you authorize to talk to, what do you authorize to share. The powertrain control module, body control module, electronic brake control module, transmission module, and other systems can be networked together. Multiplex network enables a decreased number of dedicated wires for each function. So what it allows us to do, instead of having a temperature sensor, for example, on the engine for my climate control, another one for my gauge, another one for my engine control computer, another one for my electric fan for my radiator. So instead of having 3 or 4 different sensors, it allows me to have one sensor that everybody shares. So that's going to what? Less cost of manufacturing, less weight on the vehicle. I mean, there was a time when vehicles had about 5 miles of wire on them. So with network, we've been able to reduce a lot. Obviously, copper's heavy, so the more wire, the more weight, lower fuel economy. And it talks about sensor data as being multiplexed, and it's also prioritized. So not all modules have the same priority. For example, the customer asking for air conditioning would have a lower priority than the airbag module saying, we just got in an accident, right? So there's different, or the engine module saying we're overheating. So there's a hierarchy of modules or a priority. And a diagnostic scan tool is connected to the network to assist in diagnosis. So they really overuse the word CAN bus. I don't want anyone thinking that CAN that all networks are CAN, or that's the only protocol. CAN is kind of like Android. It is an open architecture system that is used, and in some cases it's required to be used. A lot of cases it's not. So we see not everything is CAN, and even if it is CAN, there's different speeds and regulations go with each speed. So there's a lot of stuff that goes in. So the book just kind of really in this chapter, and the reason why I kept these slides in here is the book just makes everyone think in this chapter that everything's a CAN bus and all of them are connected together, and it doesn't quite work that way. That's why I have a whole separate PowerPoint I did on networks that we'll get to. Yeah, Tim, you look like you have a question.
That's just my normal look, I guess.
Okay, well, you kicked the camera on and you had a question look, so I thought you might have something for me.
Sorry. No, thanks.
No problem. So, just a couple of things. The book does talk about HID safety. Again, newer technology, a lot of concern. I already talked about the risk of electrocution, burns, or shock from the high voltages generated by the ballast in it. Anytime we're working under the hood, they want us to have safety glasses on. No one wears high voltage safety gloves. You don't need to wear safety gloves or boots working on HID, because I got news flash for you. If the headlights aren't turned on, there's no power there. So way overboard on that. Ensure the vehicle, engine compartment, and ground or the vehicle are dry. Don't touch the ballast while it's operating. Well, that's like saying, don't put your finger in the light socket with the switch on, okay? Same thing. Persons with active electronic implants, such as heart pacemakers, should not work on HID bulbs. Again, If it's turned off, there's no danger. If it's turned on and you have a pacemaker and get hit by 125 volts, 150 volts, yeah, that's a problem. Also, risks of energy exposed to ultraviolet light produced by the HID bulb if the bulb is operated outside of its housing. So we don't just turn these on outside the housing, we put them back in their housing, which is easy to do, and then turn them on to see if they work. High pressure buildup inside the HID bulb creates a potential explosion hazard. That's really only if you hit it when it's on. Bulb must be maintained in a horizontal position when it's on, so we don't pull these out and hold them straight up and down to look at them. A, we should be looking at them, and B, it's in the wrong position. That's another reason why we put them back in the housing before we check them, so they're in the right position. Risk of poisons caused by inhalation or skin contact of the heavy metal vapors or toxic salts if you break the thing. So what have we learned? Don't unplug the bulb with it on. Don't take the bulb out when it's turned on. Don't turn the bulb on when it's not in its housing. So pretty straightforward, common sense safety. But the industry is very concerned about safety with HID. So you can see where why the book has 2 PowerPoints on it. And obviously I want everyone to be safe. I don't mean to play down safety, but sometimes it's, let me wrap you in bubble wrap 300 times before I let you walk across the street. I mean, there comes a point to where the safety measures become the hazard. Okay. So we do have a lighting exercise lab that's an extra credit lab. And so I don't know if I've turned it on or not. If not, I will turn it on today. Let me check. Oops, let me hit this.
I think it's turned on already.
Okay, I was just going to double check while I'm thinking about it, while I'm switching PowerPoints. Okay. And I do have it on, and I'm going to share it here with everybody. So the goal of this is for you to perform a lamp inspection on your vehicle. So in here, and this is based on using the state lamp inspection guidelines as far as how we measure. So if you have any questions, it is in the lamp inspection manual that's in the previous assignment, which is the homework assignment where you read the manual and answer the questions. So how to do this is all explained in that. And this is worth 20 extra credit points on your lab grade. So 10 points is for filling out the inspection sheet. The other 10 points is showing me that you know how to properly measure the height of your headlights. All of this can be done during the day. We don't need to be dark or anything like that. But remember, we measure the height of the lights on the lens, not where it's shining. So we're measuring the mounting height. And so here I have a lab sheet right here. Year, make, model. And basically, does it turn on? Is there any defects? Is it any cracks, looses, etc.? Obviously, if it doesn't turn on, there's a defect. I have you tell me what your high beam and low beam light mounting height is. Now, if they're both in the same housing, they're going to have the same mounting height. If they're different, they're not. What are the mounting height for the turn signals? What's the mounting height for my rear brake lights, front fog lights if you have them, and driving lights if you have them? So those are the only things we're measuring the height on. Then I want you to identify what kind of headlight do you have? Is it a sealed beam, a halogen, high intensity discharge, or other? And what defects were found during your inspection? So just like the other lab sheets, you're going to upload that to me. So the sheet's worth 10 points And then the picture of you measuring your height is worth 10 points. So here's 20 extra points a lab in this chapter. So as I said, I try to put some extra credit in everything. This is an example of a lab extra credit assignment. And does two things. First of all, have some fun with it. It's a chance to stretch your legs a little bit. The other thing is I always have students who find that they have lights out that they didn't know. So if we figured out you have a light out and it saved you getting pulled over and having to show your license and registration and insurance, this was a great lab. So this is it right here. And what I'll say about on the book, I'll go back to modules. I also have the book up in the bar section in the top in module 1. But we are, it's right here. State lamp inspection. So you should do this first because here is the lamp adjuster's handbook, which has all the goodies in it right there. So I can go to student view here. Make it look like you guys get it. Come on. So here's what the assignment looks like. And here is the lamp handbook. And even though it's 33 pages, you can see a lot of it goes pretty quick. And it talks about the different types of licenses. It also talks about how to do an inspection in here. And this is the inspection you're going to be doing on your vehicle. There you go. So there's stuff like this that is nice. Let's see, do we have the chart handy? Yeah, here you go. So here's your mounting height chart for what your minimum and maximum is allowed on the different lights, what year it's required, and vehicle code reference. So if you want to learn more about any of these, you can actually go to the California Vehicle Code and look up and find out more about them. So that's a real handy handbook. So I have 10 questions, I think, on this off of reading the handbook. Yep, take the quiz. And this right here, there's no time limit on it. So you can go back and forth as much as you want to find the answers, and you get 2 attempts. See, so what year are turn signals required on a vehicle under 80 inches wide? Where is the height of the headlamp measured from? What is the acceptable height for fog lights? So you can see when adjusting headlights, the last turn of the adjusting screw should be in what direction? So all things based on the article, and they're all things that we actually get tested on, or the types of things we get tested on to get a license. So those are the 2 lighting assignments. Any questions?
Question I have for the multiplexing networking, and how many nodes approximately in one car?
Depends on the car.
Yeah, suppose Toyota Corolla is a 2016.
I need to look it up. I don't know off the top of my head.
Approximately, because a part of the node is a part of the communication or networking.
Right. It depends on what options it has. I mean, there's a lot of variables there. It's going to have probably somewhere between about 6 or 7 up to 20 modules on that network. Again, depending on what options you're in, compare that to a Porsche Panamera that can have over 160 modules on its networks. So we can have cars with as little as 3 or 4 modules. We can have cars with 160 plus modules. So it really varies a lot by what options did you get? What package is there? Who makes the car? So every car is different. And even if I'm working on 2 Toyota Corollas, I would still have to look up and see how each of those are equipped, because if they're different model, one's an LE and one's an XSE, they're going to have different modules, different network. They're going to have some similarity, but there's also going to be some differences. Did you get the fancy radio or the base radio? right? Fancy radio may be a computer that's on the network. The base one may just be a radio. So a lot of variables.
I got it. Thank you.
You bet. Good question. Okay, so let me share. I think I shared the screen already. Did I?
Brian,
go.
Saeed's question made me think. So the less modules, the less things break, obviously. So the lower the base model, I guess you would say, the better you are. The reason I say that is because I always buy the base models.
Right.
What do you think about that? I mean, it's a true statement that you've seen in the industry, less modules on there, the better?
Yeah, well, yeah, certainly. I mean, just like anything, you know, if I have a house with more rooms, there's more rooms to clean, right? So the same logic applies. If I have a car with more systems, there's more things that can break, therefore more things will break. So yeah, there is definitely some truth to that. I mean, it goes back to the old days. You have power windows or manual windows. Well, the power windows will stop working. My manual windows still work, right? Why? Because there's one less thing to break. Because a manual window doesn't have a switch. It doesn't have a motor. All it has is the crank and the mechanical gear. So yeah, there is something to be said for that. Certainly the more things you have on a car, the more things it can break. The flip side of that is the car with more things may actually be easier to diagnose in some cases because you're going to have a computer that'll help you diagnose a system. Where on a lower model without a computer, now I got to go in and manually diagnose the system the way I did 20 years ago or 30 years ago. Where with a computer, I might be able to sit there in the driver's seat with a tool and walk through and figure out what's wrong without taking anything apart. So like anything, there's pluses and minuses. So working on a loaded car can sometimes be really nice because you get so much information compared to a base car that might not support some of those functions. On the other hand, I wouldn't be fixing it if it didn't have them. So, you know, so yeah, there's pluses and minuses. I mean, I tend not to buy a fully loaded necessarily, but I usually buy them nicely equipped. So I get somewhere in the middle. A lot of times I get one line down from the top because that has the stuff that's they figured out works. And I don't have the stuff that they're still trying to figure out if it works. So, you know, and I tend to do that with a lot of stuff. Buy what was the best thing last year or 2 years ago that, okay, we know this works now. And sometimes you just buy what you get. If you're buying it used, hey, I like it. You know, I'm not going to buy it because it doesn't have the right trim I wanted. It's like not buying it because it doesn't have the right color seat. Some people are that way. You know, some people are like, nope, I want to buy this, but this just isn't the one I want. I have a friend of mine who's wanted to buy a Porsche for over 20 years. And he's looked at a lot of them. He's test driven a lot of them. But you know what? None of them are exactly what he wants yet. Well, the long story short is he's probably never going to buy a Porsche, even though he's talked about it for 20 years. And he's driven a plethora of them because he finds something wrong that he doesn't like with every one. And that's just reality. And so, you know, it's just like my truck that I've had for a lot of years. I wish it had intermittent wipers. It would be nice if it did, but it wasn't, you know, a deal breaker for me. It had enough other really good things.
Sir Brian, I have a question.
Yes.
You mentioned earlier that a module is a compartmentalized system, and if one module is out, the car will still work, the systems will still work. So if these systems are not in module, is it easier for the car not to work because, you know, the system is all together, not compartmentalized?
Okay, so let me back up a little bit because you might have misunderstood me a little bit. So if I have a module that goes bad, whatever module that controls, that system will not work. We compartmentalize modules in groups or an individual network. So if that network stops working, the other networks will still work. And so that way, it's like a problem with my radio or a problem with my air conditioning won't cause my car not to run, right? So we have a very small network with things like the engine, transmission, ABS brakes, and airbags. And usually there might be one or two other modules on that network because that's what we need to make the car down the road. So that's a very robust, fairly small network. Then we have all these other things, my power windows or my radio or my steering or other things, suspension on these other networks. That way, if I have a problem with my suspension, my car's still going to drive. I'm going to have lights on, it won't ride correctly, or my steering might be hard and it won't ride and it won't steer quite right, but I can still move and drive the vehicle. So we compartmentalize it so that these minor modules or these convenience modules will, in theory, not keep my car from running and being able to get from point A to point B, even if point B is just the repair shop. But the idea is not to have the car die on the road while you're in the fast lane on the freeway. So also, if a module goes bad and another module needs information that that module has, that other module can be affected, or that other module may not work, be able to perform all of its functions, even though there's nothing wrong with that module. But we do compartmentalize things and tasks into smaller areas. So instead of having one big central computer, which we could do, we could throw a big central computer in and everything goes through one computer. But what happens when that one computer has a problem? Everything has a problem, right? So instead, we've taken that computing power, instead of having one central computer, use a lot of smaller computers on a network that are able to share resource, share information. We've kind of divided out the jobs in a lot of places, trying to get some redundancy and also keep the whole vehicle from shutting down. Because you can imagine the safety issues if cars were as reliable as your desktop or laptop or your cable box.
That's exactly what I'm driving at. Instead of just one big computer, we compartmentalize so that it's easier for us to address the specific problem in each area. So that's like the advantage of having modules.
Yeah, you're absolutely correct. And that
Thank
is
you.
a huge advantage.
Thank you.
You bet. So we're going to get in now. So this is chapter 57, and chapter 57 has, it starts off with the drive-by-wire, and I have a drive-by-wire article we're going to cover later, and there's some, there's a quiz in there and all that. So it's some good background. But I'm not going to get into the technical part of it right now because we're really not ready for it. Because really to explain the technical part of it, we need to understand how engines work, and we haven't gotten there yet. So what we are going to look at is what's called adaptive cruise or radar cruise control. And this adapts to the driving environment, incorporates driver warnings, potential collision and or requirement for the driver intervention. Driver does not continually have to adjust the cruise control in heavier traffic and requires additional sensors such as radar, laser, or camera systems. So strictly speaking, radar cruise, all radar cruise does, or adaptive cruise does, is I'm able to set a distance between me and the vehicle in front of me. And I can adjust that distance between a small amount to a larger amount. So I have some adjustment there based on how close I want to follow. The adaptive cruise not only controls the vehicle speed, because we've had cruise control since the 1960s. And cruise control in the 1960s allowed me to be at a certain speed. And then if I'm going up the hill, it might slow down a little bit. I'd have to turn the cruise off, or it would, eventually come up. And if I started going too fast, it would kind of back off. But I was pretty limited in range. If I got out of that range, or if I hit the brakes, and same thing's true with this, if I hit the brakes, I turn the cruise control off. And that's the same true with this. The advantage I have with the adaptive cruise control, not in Canvas. Alrighty, I will fix that. Thank you, Cynthia. Did everything else, but not that. There we go. It's up now. So the adaptive cruise control, being able to set that distance, also allows the vehicle to come to a complete stop, and will allow that vehicle to start and come back up to that preset speed. Oh, that's pretty cool. That means if I'm if I'm going through LA, I could set my cruise control at 70 miles an hour. And when I hit stop and go traffic, my car will come to a stop behind the car in front of it. And then when that car takes off, my car will take off, and it'll never go faster than the predetermined speed. That's pretty cool technology. Now, of course, in rush hour traffic, because the following distance, everybody in the world is going to cut in front of me, and I'm going to keep backing up, slowing down because I want to maintain that following distance to be safe. But it is still really cool when you look at driver fatigue, and I end up driving through parts of LA fairly frequently, at least before COVID, and it looks like I will be after. I'm going to be teaching up in Torrance in July, and getting to Torrance, I tell you what, getting from Santa Ana to Torrance, you're lucky. It's 30 miles, and you're lucky if it only takes an hour. It's horrible. But I'd love to have adaptive cruise because it's exhausting. Go stop, go stop, go stop. So really, really nice system. And we're seeing this has been around for 20 years. This is not new. The early systems were introduced in Europe in the 90s. The early systems didn't see motorcycles and didn't see around corners. So that was kind of problematic, especially for those that were riding motorcycles, because the Mercedes would hit them. And that's why they try stuff in Europe before they bring it here, because they don't sue people in Europe the way they sue people here. So if you want to get an idea of what is coming here, look at what is available in Europe. Because I don't care if it's Mercedes or Lexus, they experiment in Europe before they come here, because you don't get sued the same way. The US has more lawyers than the rest of the world combined. So it is our national pastime is suing. You thought it was baseball. It's not. It's suing people. So manufacturers know this, and that's why a lot of new technology is delayed coming to the US by 3 to 5 years. So steering angle sensors are used to determine the vehicle direction. Some active cruise control systems also operate automatic brake control to avoid collisions. Okay, so a couple of things here. Once I look at the steering angle sensor, once I use automatic braking, it is no longer adaptive cruise. It is adaptive cruise plus steering control. It is adaptive cruise plus automatic braking. Two separate systems. It's not one system, or three systems combined. So as we build, we have this basic system, our adaptive cruise. And then if I want the car to stop because the car in front of us stopped, I got it set at 70 and the car in front of me hits the brakes, and I want the brakes applied to stop the car. Now my adaptive cruise has to be networked with my braking system, so my braking system can apply the brakes. And now my braking system has to be networked with my lighting system, so we can turn the brake lights on to let the person behind us know we're stopping. So you can see where that networking comes in. But each module, just like you pointed out, Cynthia, has a specific task. That way, if one of them stops working, we still have other features. It also allows really that dedicated control of each of these technologies. So all the books saying that that's adaptive cruise, it's not. That's automated braking. It's a different system. When I look at smart steering systems, different system. Now, I'm not saying that the information from the steering angle sensor might not be shared with the adaptive cruise so it can understand to better control the speed, but it's not going to, it's not an active control. If I want to test the cruise control system, regardless of if I'm working on an early or late system, first thing I need to do is learn how it works. Many cruise control systems that are not adaptive cruise and even adaptive cruise will not set to a speed less than 20 miles an hour. So at 10 miles an hour, you can't set the cruise on a lot of these systems. None of the early systems will set. Some of the adaptive systems will set at a lower speed. They won't set on a rack, because if I have the vehicle up in the air, only the drive wheels are turning, the other two wheels aren't. There's an ABS code. So if there's an ABS code, many of these systems will not let you use cruise control because it uses the ABS wheel speed sensors to see how fast the car is going. And if there's a code in that module, we really can't trust anything that module wants to tell us. So we're not going to let the cruise work. You see how it's really, so diagnostics is just not a matter of grabbing a meter or grabbing a vacuum gauge. We need to identify as an early system or as a later system. Is it vacuum or mechanically operated, or is it electronically operated? If it's electronically operated, we're working on a drive-by-wire system, which most of those are. And then based on which system it has, if it's a later system, I could probably hook up a scan tool to it, might be able to turn it on and off with a scan tool. I might even be able to see all the switches work with a scan tool. So I might be able to do almost all my diagnoses, or 90% of it with a scan tool. If it's an older system, I'm getting out a digital multimeter or a scope and a vacuum gauge, and I'm going to be doing testing. And so it really varies by what system we're doing. The biggest thing I find that people struggle with cruise control is knowing how the one they're trying to diagnose actually works. And by actually works, I don't mean anything high tech. I mean, is the owner's manual in the glove box, and read the owner's manual on how, what set does, what resume does, what decel does, where the on and off switch is. I can't tell you how many cars I've had come in. My cruise control doesn't work because you didn't turn it on. There's another button over here. Or they just don't understand what the buttons do. So, I'd say probably a third of the cruise control complaints I've had over the years from customers is customer doesn't know how to use their cruise control. So if I'm going to diagnose something, I really need to know how that one works. Once you've worked on a lot of them, you kind of get familiar with some of the common controls. But before you dive down the rabbit hole, make sure you're not missing something. Manufacturers love to do different things. And again, ask yourself, hey, the cruise control doesn't work, but the ABS light's on. The customer say, well, I don't care about the ABS light. I just want my cruise control to work because I'm going to Sacramento. That might not be the customer's choice because cruise control won't work with the ABS light on. And a little bit of research will tell you if that's the case or not. At the very least, if everything is working and all the inputs are going into the module that controls cruise control, but the cruise control module isn't activating the cruise, and you have an ABS code or you have another code that might go, wait a minute, the engineers might have decided to be really safe and not let this work without this. You really need to tell your customer, let's fix what we can prove is broken first and see how the computer and network respond to it, instead of just putting a module in because it has input, no output. And that sometimes that's a tough decision to have, because you're telling the customer they need to fix something that they told you up front they don't want to fix. But what they really want to work may depend on doing what they don't want to do. And that's where understanding that, nothing works in a vacuum on a car. We had a vehicle in that the backup camera didn't work. And the reason the backup camera didn't work is the right front headlight motor for the self-leveling headlight was bad. So the backup camera didn't work. Customer wasn't complaining about that. So you can watch where you're going in reverse. You need to buy that $950 right front headlight plus the labor to diagnose it and put it in.
Can you please repeat the cruise control location?
Well, the cruise control, well, are you talking about the module or are you talking about the components?
Both of them, please.
Well, the components are going to be on the engine or underneath the hood, and the module can be underneath the hood or it could be underneath the dash. It depends on the vehicle.
Okay.
And I see a question mark here. So I was waiting for that. Okay, so what led us to the right front headlight is when we found that the backup camera wasn't working and the fuse for it was blown. When we replaced the fuse, we had two more modules appear on the network. One of them was the right front headlight module. What we found was that when it worked the motor, when it tried to level the right front headlight module, it would blow the fuse, which was causing the backup camera not to work. So the right front headlight, the motor in the headlight module was blowing the fuse that controlled four different modules, one of which was, or three different modules, one of which was the backup camera. So that's why that headlight module was causing the backup camera not to work. So I was waiting for the question. I wasn't going to give it to you until someone asked.
Yeah,
That's
well,
why
I was I was going to ask you to elaborate also. Could that be because maybe the self-leveling motor was failing, requiring more, amperage and to blow the fuse?
Absolutely. So whether the gears were bound or whatever, because it didn't move it at all, even when commanded with the scan tool. But exactly, it's trying to work. And actually, during testing, we got some smoke out of the headlight module, even though it didn't blow the fuse right away when we were testing it. But it's like, here's the problem. Exactly. Because if I have a motor trying to move something that can't move or it's bound up, amperage is going to increase because it's not rotating. So it's basically a dead short at that point. It's going to pop the fuse. Absolutely. And that's great because you're putting together what? Things we learned from starters, things we learned from other modules into why a fuse would blow.
It's interesting you said that because I was thinking about the modules, and there's your modules that can affect the other modules because of multiplexing. So it's interesting how that works. So the more advanced we get, the more complex these solutions are going to become.
But again, we got there by seeing who showed up for work, put a fuse in, who's showing up for work now, did that change, and looking at wiring schematics, and then seeing what did the new modules that just showed up for work have in common? Oh, they all get powered by the same fuse that was blown. Got it. So now I know where the problem has to be is one of the modules is powered by that fuse. So now let's make each of them do some work and see if we can get the fuse to blow again or get one of the find something not working. And the smoke was kind of a clue that helped a bit. But what I said, modules work on smoke. When the smoke comes out, they don't work no more. So just like anything, once we've repaired it, we always want to test drive it, make sure it works. So autonomous driving. So you've heard a lot about self-driving cars. They've been in the news for years. You hear a lot of people say, I wouldn't drive a self-driving car because it'd be unsafe. I'm afraid of a self-driving car. It is interesting. We hold self-driving cars to really a much higher standard than we hold people. So if someone is hurt or killed because they're hit by a self-driving car, the technology is horrible. We need to get rid of it. I'd never do it. But how many people are hit and killed by people driving? By people driving distracted, by people driving drunk, by all these other things that can happen. And so we're at a really interesting crossroads with autonomous vehicles. We have the hardware in place for cars to drive themselves at this point on many models of car. We do not have adequate software yet. So if I want to have a car drive from Dallas to Phoenix, or a truck drive from Dallas to Phoenix, that's easy. We can do that today. I can program a semi or a group of semis to drive from Dallas to Phoenix. They're going to get on the freeway and they're going to drive all the way over here and they're not going to have any issues. Where it's hard is when I want that truck to get off the freeway and go to the delivery spot. City traffic is the hardest. And that's where the holdup is, because do cars always stop at a red light? Do cars always yield the left turn when the light's green? Do cars make illegal turns on red? And then you got pedestrians. Do pedestrians walk out in the middle of the street, in between cars in the middle of a block, go against crosswalks, step on the curb and then instantly step off because they dropped something that you might not have noticed? People in cities are very, very, very unpredictable. And then let's not mention bicycles, scooters, rollerblades, all those other things that changes the speed and direction. Does every bicycle follow the rules and stay on the correct lane, or do they go the opposite direction sometimes? So you got all these people and all these things that break the rules. Freeways are easy. Everyone's going the same direction. We have a lot of rules. That's easy. We've been driving trucks autonomously in Europe for years on freeways. And the post office just did some stuff between Dallas and Phoenix is why I chose that. Freeways are easy. And matter of fact, the driver assist systems that we have today are designed for freeway use. That's really where they're designed for. I get to the freeway and then I can turn on these assist systems, and I still got to keep an eye on what's going on. I still got to keep my hand on the wheel in many cases, or at least be looking forward on others. And based on that, we're going to be in good shape. We can deal with people changing lanes unexpectedly. We can deal with people stopping unexpectedly. We got this. Cities are where the holdup is. So if we look at the evolution here, autonomous 0. This is the driver is control of everything. 0 level. Then we come to level number 1. So this vehicle operates steering or acceleration, deceleration in specific cases. So this is your adaptive cruise. So again, one function is assisted. So this is, I have something, I'm here, and I work by myself. So I might have automated braking, but not adaptive cruise. So this car will keep me from rear-ending somebody, but it doesn't have adaptive cruise. By the time we get to autonomous level 2, now the driver must observe and drive and be ready to resume full control. But now we start combining things. So now I'm going to combine maybe my adaptive cruise with adaptive brake with the augmented braking systems. I'm going to adapt adaptive cruise with my smart steering that's going to help me stay in the lane even though I have a cross breeze. So now we're combining 2 systems. So it's not just that there's 2 systems on the car. Level 2 is we've actually allowed them to work together to perform a more advanced function. When we get to level 3, which is the driver does not need to observe the drive, but must be ready to resume control shortly after alerted, vehicle can be operated and acceleration, deceleration, specifically recognize limits, alert, driver, maintain control. So this is where we combine our adaptive cruise with steering capability with automatic braking. So now I have a car that can steer, accelerate, decelerate, and brake. That's where we're at right now. We're at a high level 3 right now. There's no manufacturer that has anything past that. So we are high to mid-level 3. Tesla probably has the best technology out there right now. Now we get to level 4, no driver needed. The issue we have is we have a lot of people with level 3 cars thinking they're a level 4 car. So the vehicle can operate under limited driving conditions. Again, still limited, not everything. And we don't need a driver under those conditions. So this would be, I can get on the freeway or get in certain conditions, tell it where I'm going and take a nap, wake me up when I get there. I can read a book, I can play video games, I can do it because you don't need me at all while you're in control. I don't even need to be ready to take control. I don't even need to look around if I don't want to. I can take a nap. Level 5 is full autonomy, no steering wheel.
I like that.
So
I can just tell the car to go where I wanted to go, and it's just like having personal chauffeur.
right. And I personally am hoping they get this in gear before my kids take my driver's license away from me. So because, you know, I am banking on this. Let me tell you, I don't want to go live in a rest home or an apartment. I want to live where I want to live, but yet I still need to get to the store, still need to get to medical appointments, still need to be able to go do things. So I see autonomous vehicles, and I think you're going to see the development of them continue to really accelerate. because of the amount of freedom it's going to give senior citizens. I mean, there's a lot of senior citizens that now live in assisted living facilities, not for medical issues per se, but because they're not allowed to drive anymore. So, you know, for one reason or another, they're not allowed to drive. So it becomes a huge mobility issue for seniors. If it's a self-driving car, if I'm at level 5, can I put my 6-year-old in it and have it take my 6-year-old to school? Is that going to be allowed? If not my 6-year-old, how about my 10-year-old or my 12-year-old? Because they're not driving, the car is, right? What does that mean for the taxi business? Why do you think Uber and Lyft are spending so much money to try to get to level 5? How many drivers do you need with level 5? Oh, gee, that just cut down our overhead.
But what kind of traffic rules would there be? Who will be the liable person if this gets into accident? Nobody's driving. Should we sue the car?
Well, that, you know, you laugh, but that question has come up. That question has come up a lot. And because it's the software that's driving it, isn't it? So
Or is it the liability of the car manufacturers?
it'd
Because
be the
car didn't
liability of
work.
the car manufacturer software. So now insurance companies, being who they are, will still insure that. And I bet you the loss rate's going to be lower than it is now. So because the liability is certainly not any higher, it's probably a lower liability. So insurance companies are going to be more than willing to provide insurance for that. They cover it when the computer's driving. But that question has come up. It's like, who I don't want to get sued because my car hit somebody when I wasn't in it, right?
Yeah.
And you know, so you know, part of it is, hey, it's all controlled by software. Part of it is insurance, because the loss rates will be lower. We're going to have fewer accidents. Insurance companies insure people now when we have plenty of accidents. So that's not going to really change. And but it is a great point. The other thing is the car, you know, the thought process of cars is changing a lot. Do we really need parking lots? Do you really need to own a car? So, you know, years ago, if you opened up the paper, you saw that, hey, we're selling this car from this price. If you open up the car ads today, we're selling this car or leasing you this car for this much a month. They don't advertise the sale price of the car. They advertise the monthly payment, don't they? I mean, if I open up an ad in the newspaper, not that there's many newspapers anymore, but even if I go to a manufacturer's website, they're showing me the $199, $299, $399, $499. What car do I want to get? Here's how much a month it costs me. They're selling the monthly payment, aren't they? How about CDs, yes. Right? Or DVDs. People used to buy CDs, right? A lot of stores sold records and then CDs. What happened to all the record stores? Or do people now have a music subscription? What happened to all the DVD rental, DVD stores, places people bought DVDs? Best Buy hasn't had them in years, right? Why? Because people have what? You know, Amazon Prime, or they have Netflix, or they have whatever, right? So they're not buying, they're accessing. And so really what they're looking at, because we know how fast technology goes by the wayside, what they're looking at, especially in urban areas, is people really not owning cars anymore. You're going to pay X number of dollars a month for a car service. And that car is going to be able to run basically 7 days a week, 24 hours a day. And it knows when it needs to come in for service, or when it needs to be charged, or when it needs any of those things. And you're going to pay for a service. And just like other apps on your phone, I need to go here, and there's going to be a car that's going to be there. And the concept is that therefore you don't need parking in apartments. You don't need parking in houses. You don't need parking space. So now how how many more people can live in the same density because we don't have all this parking, the structure? Will that lower the cost of housing because we can now build you a place on a 3,000 square foot lot instead of a 7,000 square foot lot? So therefore, on the same acreage, we can put in twice as many houses. And that's really, there's a big push to go that direction. There's actually a community in, it's the Phoenix area, I think it's Glendale, that they're building houses with no garages and no parking area for residents. There's a small parking area for guests. It is all based on the concept of ride sharing. It's all based on the concept of you don't need to own a car to get anywhere. And that is really gaining momentum in certain circles. So that means we're going to see cars, and even Tesla's model, because they are investing more in artificial technology than any other company is. And how they do it is really unique. Most companies, they take these cars and they pay people to drive them. And they're connected and they're gathering data, and they put 1 million or 2 million miles on these cars. What Tesla does is, if you have the package, the software package, part of what you agree to is your data is shared with Tesla. And Tesla has 2 computers side by side, and they look at something and they go, I think that's a bicycle. And the one goes, yep, that's a bicycle. Cool. But if one of them says that's a bicycle and the other one says, no, that's a car, well, they're going to do whatever is the most conservative choice or whatever is the safest choice. And then they send all that data, all the camera data, everything up to Tesla. And then Tesla looks at this, humans look at it and go, okay, what confused them about this? Oh, the bicycle was attached to a car. So one identified it as the vehicle, the other one identified just the bicycle. They need to understand that this is a car with a bicycle on a bicycle rack. So now what we're going to do is we're going to show 100,000 pictures or 10,000 pictures of cars with bicycles on them, until the computer every time recognizes, oh, that's a vehicle with a bicycle rack, whether it's a bus or a small car, whether the rack's up front, whether it's in back, doesn't matter. Soon as it learns that, now that upgraded learning is downloaded to all the vehicles. And Tesla has about 500,000 vehicles on the road doing this. And that's why I say Tesla is doing better with the artificial intelligence than anybody else is. I mean, you hear about Lyft, you hear about all the ones driving their cars around, trying to gather this data, trying to make these mistakes. The edge Tesla has is they have so many vehicles on the road with this technology that their consumers are actually gathering the data for them. And that's huge. I mean, and that really shows you Tesla is a software company that happens to build cars, or they're really a technology company, not a software company. They're a technology company that builds cars. Everyone else is a car company that's trying to implement software, or in the case of Lyft, they're a transportation company that's trying to figure out how to get a car that they can provide transportation cheaper. So Tesla is very, very unique in this market. And so again, a lot of learning. This excites me. I love this technology. And keep in mind, my car has none of these things because it's a 2012. But I love this technology. This is the future. It's also seen as a green technology. Yes, Cynthia, you had a question?
Yeah, I wonder what will be our car premiums with this technology. Will it go down because we have lesser liability, I guess?
I'm sorry, what will go down? I didn't get all that, Cynthia.
What kind of insurance premiums will this technology kind of like call for? Will it lower our insurance premiums probably?
Yeah, we're already seeing that with some of these features that, I mean, just like if you have a car, you get a discount for ABS brakes on the car. You get a discount for airbags on a car. Some of you may not have old cars that don't have those things, so you don't notice that. But You know, I have cars with and without those features. So I see on the newer cars with my insurance companies, there's an airbag discount and a, you know, ABS brake discount and stuff. So they do know statistically that those features create fewer accidents. And by the same token, when there is an accident, normally the car is totaled. So you're going to have fewer accidents, but when there is an accident, they tend to be more severe. Because at that point, it's really kind of an unavoidable accident. So all those little fender benders, all those little oopsies, these systems really avoid. So now you're in the major, something really bad happened, whether someone ran a light and hit you, whether something, you know, something really unforeseen happened. But yeah, I do, it is going to affect that. But again, their insurance rates go up every year. So at the end of the day, I think our rates are still going to be higher 5 years from now than they are now. I don't care how much technology we get. Because I can't believe how much car insurance is. So what I did here is kind of showed you ADAS to autonomous. So here are level 1 and level 2, driver assistance, everything on, and then partial automation. And level 3, we start getting into some hands off. So we went from everything on, hands and feet are on. Now I can take some of my feet off. I got adaptive cruise. I don't need to worry about the braking and the steering on the highway. I can relax a little bit, but I still have to steer. Once I get to level 3, now the computer's going to steer for me and accelerate and stop. And so we're at a high level 3. So we're conditional automation. So I can do this on the freeway, but not on city streets, things like that. Then you get the high automation, which no one is at right now. Tesla was hoping to get there last year, and they still haven't. They are getting better. I think their newest software actually sees stop signs and stoplights now, so that's cool. Because when I went to the training on Tesla, they were showing their prototype that was able to recognize them. So that was new. That's one of the issues we have is these systems don't recognize a stop sign or don't recognize a red light or a yellow light. Again, these are, and again, it's hard for computers because that yellow light, how long is that light yellow for? Doesn't it change by the signal? Because that's not really standardized, is it? Some signals have a very short yellow light, other ones have a very long yellow light. So are we going to require that to be standardized so our automated systems know exactly from the time that light turns yellow to when it's going to turn red? Would that add safety? It would. So the question is, are we going to standardize it so the computer knows that? Because for people, it's not as critical.
How about we get rid of the lights? Once it's all automated, do we need stoplights?
Well, that depends. Do we have communication from vehicle to vehicle?
That's
and
what
do
I mean.
we have communication from vehicle to infrastructure, right?
Yeah.
So theoretically, if everything was autonomous, you would need infrastructure to set the clock for the thing, but you wouldn't need physical lights anymore, and you'd know what the signal 3 blocks away is going to do. And we are working on currently not getting rid of the lights because of how many vehicles are out there, but we are currently working on vehicle to infrastructure where the vehicle, and that's why 5G is being pushed so hard, because that's our vehicle to infrastructure, is that 5G technology, is the ability to know that, hey, here's the sequencing on the next 5 lights. So even though it's a 25-mile-an-hour speed limit, if I do 22 miles an hour, I'll never have to slow down and I'll make it through all of these. So there, and again, that gets into that green technology, because instead of that stop, start, stop, start, if I can stay at a constant speed, we're what? Saving energy. We're using less fuel. They did an interesting study where they had 10 cars going in a circle, and one car jumped on its brakes and came to a complete stop. And then it started to go again. And what happened is the circle never got going again with drivers in it. It was always that, you now had traffic, right? They replaced 2 of the 10 vehicles with autonomous vehicles, or basically level 3 vehicles, which we have today. And what they found was the circle never stopped. So when we think about traffic flow, we think about rush hour, we think about the 805 at 4:30 in the afternoon. It's a parking lot. And, so the concept is we don't need all the vehicles to have these features. We need a certain percentage of them to get there, and that's going to alleviate traffic. The other thing they're looking at for the express lanes in California, currently it's a white sticker in order to be on the express lane for free. The next thing they're looking at is, instead of electric vehicles, autonomous. So once you hit that fourth level or a high third level of autonomy, they're looking at, that's the next thing. If you want to get that carpool pass, you need to have a vehicle with that level of autonomy. So that's the next thing they're looking at, because it's seen as a green technology, which is, you know, really interesting, because all you hear about green technology is we're going to plug a bunch of cars into solar panels. You don't really hear everything that's going on and everything they're looking at. And, you know, and again, how much longer are people going to own cars? Well, I think in rural areas for a long time. In cities, maybe a generation. You know, because why would you pay for parking? Why would you deal with maintenance? Why would you deal with reliability if you can just have an app that's the same money or less money a month than just the car payment before you pay for parking? I mean, what's parking in New York City for I mean, shoot, they sell parking spots in New York City for over $100,000, for crying out loud, in covered parking. I mean, so how attractive would an autonomous vehicle be in a place like that? Wait, I just have a service and all I got to do is, I mean, they're already using taxis and limo services there. What would it take for those to be autonomous? Is that going to happen in the next 20 years? I think it probably will. And that's going to really change a lot of things, because you no longer need all that parking. You no longer need, you know, a lot of that infrastructure. On the same token, I'm feeling pretty good, because these things are all going to break. They're all going to have weird problems that the computer can't figure out. They're still going to need someone who knows how to read a scope, who's able to apply logic, and who's able to figure out what's wrong with these cars. And they're going to be racking more miles on these cars faster, which means I won't be working on as many older cars, but I'll be seeing cars break at much earlier in their life because of their higher mileage and more use. So, you know, from a job security standpoint, I'm feeling pretty good. You know, if I owned a car wash, I'd be a lot more concerned. If I had a parking garage, I might be wondering about it. But working on them, people still need to get places. They're still going to be braking, and they're going to go through a lot less breaks. They're going to go through a lot less, you know, what we call maintenance items. And what are we going to need? People who can fix what? The electrical, the electronic, the logic. That's where it's going.
So the training on these cars will be manufacturer specific. Shouldn't manufacturers start, like, you know, putting up schools for training for these technicians?
Manufacturers do that now for their dealer technicians. And then what we do in the aftermarket is we look at that stuff and we find new ways to fix it. And we also provide training. So I think you'll still see both avenues of training. And, you know, just as we do now. But I think the aftermarket is going to have less time they're not going to have that 5 years anymore, because cars may not be on the road 5 years. Tesla's idea is to offset the cost of the vehicle. Is you buy the vehicle, but you basically rent it back to Tesla as an autonomous ride sharing vehicle. So say I drive from Fallbrook to San Diego, instead of having my car sit in the school parking lot, Tesla gets to use it for ride sharing from the 5 in the morning until 1 or 2 in the afternoon. And then that car is back in the parking lot ready to take me home. And then I get paid for that ride sharing, which will offset my payment. So even though the car will have extremely high miles in 2.5 to 3 years, I will have already paid for it in that time, because it's generating income at the same time. That's Tesla's model that they're looking at. Now, for me, I carry a bunch of junk in my car. I always got books and other stuff. I'd hate having to clean out my car every time I leave it. But and what happens if you got to go someplace in a hurry and your car's not there? Well, then you're waiting for your car. So I think that's the exception out of the rule. But it is an interesting way of offsetting the price of a vehicle by giving you an avenue to literally lease it out or lease it back to them for autonomous ride sharing.
So Tesla has to maintain like a number of fleet of cars to be able to service a lot of
Right.
ride sharing customers.
Exactly. So really, like, again, a lot of this is kind of pie in the sky. A lot of this is some of the forums and some of the workshops and expos and stuff that I go to, because I love hearing what people think or where they think they want us to go, because I understand politically that's where it's at right now. So even if the technology is not there, I know what's driving it. And if I want to be in the business of fixing it, I need to pay attention to that. So on the chart here, I put in 2024, they're expecting level 4 high automation to be in. And level 5, 27 to 30 is their goal. That's not that far off. So I am very optimistic that I will have options by the time they try to take my license away. I'm hoping for the best. I think this will also change how people travel. I think a lot of people would rather fly than drive because they don't want the exhausting experience of driving. Well, if I can hop in a car and a car is going to just take me somewhere, and I don't need to deal with the fatigue of driving, and I can do something else while I'm in the car. It'll be interesting to see how that changes traffic patterns.
Because nobody likes or knows how to merge. Everybody wants to one up the next car.
Yeah, the whole concept of a zipper, it's amazing. Everyone owns one and no one knows how it's supposed to work.
They just ride that merge lane into the very last second possible.
No, and the concept of every other car, it's like, hello, if you just, a zipper, it's not complicated. And we do have a lot of collision avoidance systems, but instead of getting into those right now, I'm going to stop this and we're going to show some stuff to you. Because I figure it's Thursday and I figured you guys deserve a video today. Let me pull it up.
Everything's green. According to this, it's happy.
Okay, hold on a second. Doggone it. Don't want that. Stop. Okay. Boy, trying to get it to cooperate with me sometime. Okay, so we're here. All righty. So this right here is a video, several videos I took. First one is on a Mercedes. The second one's on a Cadillac. Both of these systems have a couple automated systems. The first one, the Mercedes, we're going to be driving on the freeway. It's going to use its adaptive cruise. It's going to use its automated braking, and it's also going to use its steering. So this is a level 3 car. Mercedes says, and it was 2012, 2014, somewhere in that range. These cars had all the hardware necessary for autonomous driving, just not the software. And the person who's driving the car really doesn't think much of the Mercedes. I actually got a little car sick filming this because it was jerky, but it was interesting. Some of the things it did, some of the things it doesn't do, some of the things it doesn't do well. So the Mercedes is first up. After that, we're going to look at a Cadillac.
Everything's green. According to this, it's happy.
So he's looking right in here. And when this is green and sees the lanes, it should go green and it should be hands-free. So he's trying to get it to set. And see, he's very apprehensive. He doesn't trust it.
So it's just silly.
Now, this requires you to touch the steering wheel every 10 to 20 seconds so it knows you're paying attention. And Tesla, other ones all require this. There are people that do things to get that to full, but you can see here it's steering around the corner. It's controlling the speed. He's foot free, hands free. He just turned the turn signal on, and the car itself changed the lanes for him just by turning the turn signal on. See, he doesn't trust it. You hear him saying slow down. He's not trusting the car at all. He does not like the Mercedes.
Touch it, yes.
And the ding was it wanted to turn it. Now what's interesting is it was only supposed to go one lane and it went two. And you saw him grab control. And the reason why it probably did that is, see these square dots here compared to the normal dashes here? So the computer did not recognize these square dots as a lane separator. So it's going over wanting to go through one line of dashes, and it's going to go over till it sees what it recognizes, then stop going. And we did this 2 or 3 times. I was in the car on this particular one, either in front of it or behind it. And this car did this every time here. And the reason is because their system, because they're using a camera. So we're using a camera to see where the lane is. And it doesn't recognize these as lane separators, which is pretty common with these systems. So that's what I was talking about. This is a constant learning process. Things that we take for granted that, oh, everyone knows that. The computer doesn't. And we don't find out what it doesn't know till we start doing some of this stuff.
So the programmer just have to input those kinds of dots for the vehicle to be able to recognize it, right?
Exactly. And that's where Tesla has the edge, because this happens, and Tesla doesn't have this particular feature, even though they use the same steering column. They use a Mercedes steering column. It doesn't have this particular feature, but that's where Tesla has an advantage, because if something happens like this on a Tesla, the computers are sending that information back to Tesla. Tesla's analyzing it, and they're able to update the software, where other manufacturers are not able to do that, because Tesla is actually updating their software through the cloud, where all other manufacturers require the vehicle to come into the shop for updating of the software. GM with Cadillac is doing some minor updating through the cloud, but not to the level that Tesla is.
I got a question, Brian.
Yeah.
In some of these things you've been to where they're talking about the developing the technology and whatnot, what about this scenario, and has it come up? Obviously, a lot of this is dependent on a standardization of all the painted lines and little markers throughout. So that's one thing. But what about road work? What about construction areas? How do you have autonomous cars come upon a thing like, whoa, this is a completely different traffic pattern. The markings aren't there. There's a guy with a flag. What do they talk about in those kind of scenarios at these forums and whatever that you go to?
Well, and that is the holdup. All those scenarios you talked about is why we're still looking at, 6 to 10 years out, is because those are the hardest things to teach a computer. Those are the hardest things. What if they just sandblasted all the dots because we're reprogramming? So right now, what we do is we just turn the systems off. If the camera doesn't see the things it wants, it alerts the driver and says, you got the football, right? It basically just, it turns itself off. It says, it's all you, handle it. That's why you're here, Mr. Driver. And that's where we see, things get in trouble sometimes when drivers don't handle it, or when drivers don't take control because they're abusing the systems. But that is a real issue. And we'll see right here, we're using GPS and we're using cameras. Cadillac that we're going to look at in a minute, which is a much better system on the road, but it uses maps that GM has bent, because they don't trust Google's maps, which means it only works on highways that GM has mapped. It won't work on every road. So it's limited, but much more accurate, and it's using cameras. Where Mercedes is using the GPS based on Google Maps or whoever else's maps and saying this is good enough. So GM doesn't trust, so they're actually investing the money in their own mapping. And with GM, if your subscription to OnStar is more than 6 months old, it disables all the self-driving function, because roads change, markings change. So they're renewing their maps on that 6-month cycle for the roads they support. Now, obviously, it's not supportable to do that with every road. So we're down to pretty much major highways and freeways is all the GM system works on. But we'll see it works really well and for long periods of time. Tesla's is unique in that it's using cameras and the GPS, but it's also able to learn roads you travel. So if there's a road they haven't mapped or they're not familiar with, their system will not work perhaps the first couple of times you drive on that road. But after you've driven that road a couple of times, now it knows that road and it'll let you use some of the autonomous functions. So that learning really makes Tesla unique. And I'm not here to sell Tesla. I love the technology that they're doing because they're just really pushing the envelope. And to me, that's exciting. I mean, I really enjoy how they're, just like you said, how are you overcoming construction? How are you overcoming the guy with the flag? How are you overcoming the car that's making the illegal U-turn on a divided highway where you got 2 lanes each direction in a dirt median? The guy decides to come across and cut across you that no one should ever be doing. How do we handle that? And, you know, as a rule of thumb, we apply the brakes. When all else fails, stop the car. Right, you know, so it's fascinating what we're doing here. So let me go ahead and play a little bit more on this.
There we go. Now I got a green. I'm afraid to let the thing go. Now does the green indicator those come under? Yes.
So there's the green indicators right here on the side. You can see the road. Now he's used the turn signal. See, it's turning the steering wheel to change lanes. And again, it's not recognizing the solid white line as the end of that lane. So for a high-end car, it was probably the worst one to drive because we're doing the Cadillac CT6 next on this video. I also did a Tesla and we did a Subaru, and I'll show you some stuff on both of those next week, especially the Tesla. And I'll probably show you the Tesla after I talk about the technology a little bit more. But the Cadillac's pretty cool because the Cadillac, we're going to go down the road in it. Then we're also going to show you the automated braking in it, both forward and reverse. And we're going to show you the self-parking feature for it. So, now remember, this uses a mapped system. So this only works on roads that are mapped. And the mapping has to match what it sees. So if there's construction or they repainted, it won't work.
I think that's what makes all of the difference.
So we see our speed right here. You can see the lanes, very similar. Again, we're using cameras.
Struggles with, it seems like we can see we have the short lines and the long lines. Even when I'm centered up, sometimes it can't find the lane size, and that's what it's telling me. I just hit it.
See, it doesn't like the dots.
It doesn't, like you hit the button, all of a sudden it'll engage whatever. You hit the button, and it's either going to give you a yes or a no right now. So there's no surprises. Same thing, says I'm not in the center, because now we have a solid line. Right. There we go. It turned green. No feet, no hands.
See it like the solid line. They figured that out. See, green tells we're good to go. So the feedback on Cadillac's pretty cool. You get the green in the steering wheel.
Yeah, that's cool. I like that in the steering wheel. I haven't seen that.
Apply the brakes all the way to stop if necessary.
That is cool.
See, he's no feet, no hands right now. Maintaining our speed. He set the distance he wants to be from the vehicle in front of him. And see, he's talking about driving from Chicago all the way to down to Dayton, hour and a half, never touched the wheel. So
that one doesn't require you to, you know, every 20 seconds, like you said, that one must not require that, huh?
No, it doesn't. But it still has to know you're paying attention. So what Cadillac does is there's a camera mounted on the steering column facing the driver. And you're going to see in a minute that he puts his hand over it. And in 8 seconds, this thing gets mad because it can't see your eyes. So how do sunglasses affect that if they're too dark?
Yeah.
I don't know, right? I mean, so as we have these technologies, what do we get? It's all about asking questions. And the other cool thing is, by driving a lot of vehicles, what it allows me to do working aftermarket that the dealer techs don't get to do. Dealer techs have something and it doesn't work or it doesn't work well. They don't know why. When you drive other things, you go Cadillac. Okay, Cadillac is where the Mercedes was like, Yeah, it doesn't want to work, doesn't want to work, doesn't want to work. Okay, it finally catches. Cadillac is, I can't see the center. I can't see the center. You can see the line change. I can see the center. Okay, you can have it now. So Cadillac, because the feedback's better, they're using similar technology. You can see that Cadillac doesn't like the dots. It likes the solid line better. That's probably why the Mercedes is having the problem, because again, it's the dots. So you're able to start drawing connections in the technology, because the technology is shared, even though they do it slightly differently. That, oh, if this guy has a problem and this isn't working, maybe it's the problem this other manufacturer is having. So it allows you to really understand the system. It's not just about understanding the vehicle. Each vehicle is a little different. It's the system we want to understand. So he just talked about how he drove from Chicago, and we're in Dayton, Ohio right now, all the way down to Dayton. No hands, no feet, the whole way in the Cadillac.
The camera on the driver is also good for biometrics identification, so nobody can steal your car.
Yeah, that's another use for it, isn't it? See, he's got his hand over it. See how it's blinking, telling you I can't see you. The seat vibrates to wake you up, and then it goes to red and says you're driving. So the adaptive cruise is still on, but you need to steer it. And these are all up on my YouTube channel if you want to see them again or hear better audio or whatever.
So, Sir Brian, you can drink and drive now?
Not yet. Hey, they're fully autonomous. They're probably going to have bars in there, right?
Yeah. So there will be less DUI, you know.
Absolutely. There was a lot of advantages. I think it's also really, I mean, we talked about how the starter really changed who could drive, accessibility, how we get places. We went to modern fuel injection, modern fuel systems. So cars now last 300,000 miles instead of 100,000 miles. You're able to go a lot more miles without having to stop at a gas station and check your air, your water, all that stuff. Is increased mobility. This is the next thing that's really going to change how people use cars, is these autonomous systems. See, and it's slowing us down because the truck is slowed down. So he hasn't changed the set.
Yeah, only that one. Now, if you try to change lanes, so if I grab a hold of the steering wheel, put pressure on it, it will actually turn blue. So that's kind of like an intermediate. Right. It's like, what do you want to do?
Yeah. So this one, you manually change lanes, blue, then you center yourself up back to green, and you're in the next lane.
Slow down. Now we're down to 53.
What's great about that is it keeps you can keep your eyes up too. Like I've got this on my Ford Explorer, and to see if it's seeing the lanes or not, you know, you're looking down and trying to read the instrument cluster instead of this. I love this on the steering wheel. That's a great idea.
It is. And some of these also have some heads up display where they're reflected on the windshield also. Because I understand if you're staring at this, you're not looking ahead and the car is not in control yet. But the feedback on the Cadillac is the best of any of the ones I've seen. I like the steering wheel. The other thing this does has two motors in the seat. So if it thinks you've fallen asleep or you're not responsive, it sort of flashes. Then it starts vibrating. And the motors in the seat not only vibrate the heck out of the seat, but they're loud. And so it's this buzzing, vibrating. I mean, unless you've had a heart attack or a stroke and you are comatose, it will wake you up. I mean, it is really. So I think the feedback in the Cadillac system is the best of all the ones I've looked at.
Time it happened to me just here.
So third,
they were trying to get
hand off.
real close to me. It shut it off immediately. Okay, because it's like I'm not sure exactly. That vehicle was waiting for me to let them in. Well, obviously this vehicle doesn't know that. It's just gonna say.
And that's that Mercedes we were in on the first test drive right in front of us. So next up is our collision avoidance system. So we're going to drive forward and we're going to try to hit our crash dummy in front of us.
Yeah. So we just cruise on as long as you're on the throttle. So I'm like.
And we're not going to go real fast here.
It's going to apply the brakes pretty.
Because we don't want whiplash.
Yeah, we're at 9. I'm not paying attention.
So this
Puts
is
on the gas and it stops the car.
Yeah. So level 3 has a handoff.
Coasting backwards.
But how it control the lane? How it control through the GPS or how?
Well, the lane is controlled with cameras.
Wow, camera.
Cameras, using cameras. So obviously if it's raining, the road's not marked well, heavy fog, the automatic driving system is not going to work.
Okay.
Does it use automatically set the distance, or do you have to manually set the distance
You
for
have a
stopping?
choice between a short distance and a long distance. And so once you set that, it's going to maintain that based on the speed you're going. Because obviously, if I want a short distance, I can have a physically shorter distance at 10 than I can at 60, even though it's a short distance. So it really comes down to how tight you want to be. So it gives you a range. And the Subaru does this. A lot of they almost all do this. Between, do you want to be as close as possible, as far as possible, or somewhere in the middle? So if I'm in stop and go traffic, I might want to use a shorter distance to keep people from coming in. If I'm going across the desert to Vegas, I might want the longest distance. So I can control that. So it's going to be within a minimum and maximum safe distance. And then the computer maintains that distance for you based on speed.
If you set the distance and it's not in the minimum of the car's specs, will the car override that, or how does
No,
it
your
work?
distance is only between the minimum and maximum specs. You don't get to choose
Okay.
how many feet. You have a choice of, the lowest to the highest in that range.
Okay. I like this car. How much is this car, sir?
How much are the cars? It depends on the car.
It's cool.
It's cool.
Like this car.
It depends on
I
the
like
car.
the steering wheel.
Yeah, it depends on the car. And like the Subaru that they had there, it was a WRX with all the stuff. It was 35 when they bought it. And when I was looking at new Toyotas, a lot of the systems that were a $5,000 extra last year are included this year. So again, as you see these things happening, what's only available on higher end cars, you're going to see, I mean, we're in a Cadillac, you're going to see this eventually end up in a Chevy, right? You're going to see it move down. So, what you might have to pay a lot extra for this year may be included next year. So that's, things to think about.
So it could be standard. It could be standard in the
Exactly.
other vehicles.
Absolutely. So, I mean, one reason why I'm kind of dragging my feet is I'd like some of this stuff to be standard. I don't want to pay an extra $5,000 for it, but if I'm going to change cars, I'd sure like to get some of it. So we're at 10 o'clock. We'll finish up this video on Monday and we'll talk a little bit more about the automatic braking. And we were only at 9 miles an hour. You'll hear him in the video say he's done this up to 30 miles an hour and it does it. And this is cool. This is actually one of those foam covered things like they use for football players to hit or other things to hit. So this was our crash test dummy we got to use. This is the college right in front of me here. And this college, all that's taught in here is automotive, and then they have a fire academy at one end of it. But this is all automotive. This was a huge, beautiful facility on its own lot, separate from the main campus. And this is a junior college. So really a phenomenal program they have at Sinclair here in Dayton. And really it was neat. It was neat seeing another school and seeing how they do it. But they hosted this. They'd gotten a grant, and this was all under grant funding that brought us there. But they bought this Cadillac, bought the Mercedes, and bought the Subaru all under that grant funding for us to play with. So it was fun getting to play with this stuff. I did this 2 years ago, almost 2 years ago now. I think it was 2. Time flies. Kind of.
We need to do something like that, Brian. Get those grants.
Yeah, I keep working at it. Trust me. So. I mean, you've seen how much stuff I've had shown up. That's come from grants. So I'm always looking, always working, and I bring some of the stuff and they don't want to go after it. And I go, fine, if you won't give me the stuff I want to go after, find me somewhere else. So that's kind of, I think, leverage some of the stuff we've gotten is because I've kind of beat them up on stuff they wouldn't let me go get. So interesting stuff. You guys enjoy the video?
Oh yeah,
So,
definitely.
So we'll start
Yes.
with, what's that?
Oh yes, we enjoyed it. I enjoyed the video.
Good. So
Actually, I'm thinking right now about the car salesman. They should enroll in Autotech so that they can introduce the features of the car.
yeah, absolutely. And you know, think about if they did something like this at a dealership and had people come out and experience some of this technology. And I mean, people
Yeah,
would
because
feel more
sometimes,
comfortable, and I think people would want it. You know, I mean, so it's neat stuff, and some of it's working better than others, but the fundamental technology is awesome, and we're going to play with this both in forward and reverse. And I'm going to show you the self parking feature in it. Then I'll talk about some technology, and then we'll probably look at Tesla after that. So we'll look at some talking and video, and so we're going to be working on this on Monday and finishing up chapter 57 Monday. Because we're also going to get into airbags. So we may not finish 57 actually. It may take a little longer, but usually probably an hour for this, hour for airbags on Monday, something like that. If it goes over, that's fine. But really neat stuff.